ANENG AN-CM82. It is a CATIII600V 6000 count LCD skin auto winking cam meter. Its size is a 185 x 65 x 30 mm. It weighs 165 grams. Battery is a AAA 1.5V 2-piece. DC watt is a 0.001V to 600V. AC watt is a 0.001V to 600V. DCM is a 0.01A to 600A. ACM is a 0.01A to 600A. Resistor is a 0.1 to 60 MΩ. Capacitor is a 0.001 nF to 60 MF. Frequency is a 0.01 Hz to 300 kHz. Temperature is a minus 30 degrees C to 1K degrees C. It has die function, continuity, inward current, spread light, and whole key, and NCV test, and inverse current, and peak voltage test, and frequency display, and have a high resistance AC voltage measure 10 MHz, and a low resistor voltage test is a 600 kΩ. It have a AC current measure frequency function and AC voltage frequency test function. Okay, let's see the meter. Let's open the meter. They come with English menu. Carry bag. Cheap white strap. 2P of AAA battery. And a meter. And a cheap temperature sensor. And a test pen. The test pen is CATIII600V 10M. They have a cap in the top for protect the tip. Let's open it. It's very soft. But this one is a PVC cable. It's about 64 cm long. And they have a cap. That's a 4 mm cap. And the meter drop size is about 50 mm. 30 mm, sorry. About the mix. Mix is 30. Okay. And let's see the meter. The meter is a CM82 6000 count AC/DC current cam. It's TRUERMS. In the bottom side, I have a COM port, a wet test leak port, and it CATIII600V. In this one, they have a input is a die, continuity, capacitor, temperature, watt, hertz, and the NCV test. And they have some key. There's a power on off key. There is a voltage AC/DC key for low resistance. Low resistance ring is about 600 kΩ. And that is a voltage, high impedance voltage test function. It is a 10 megaohm impedance. And this is a and die test and continuity test function. And this function is a capacitive function. And this is a temperature function. And this is AC/DC current test function. And that is a select key and NCV select key. And there is a inverse current and peak value key. And in the right side they have a Hertz key and the variety key for DC current measure. And first open the meter. And in this wing is a low resistance wing. They have a low Z come out. And now is in the DC voltage. Put this with again for AC. In AC they have a Diode display. They have voltage and Hertz display. And upper is a high impedance voltage test. In the first time there may be DC. Put this again for the AC measure. And the next key is a resistance test. First is a resistance. Put again is a die test function. Put again is a continuity test function. And next function is a capacity function. That is measure the capacity function. They have a reading come out. And next is a temperature function. When plug in the temperature sensor, there may be have a temperature cells or fairy come out. Okay. And next is a AC current test. The first time is a DC current. But again maybe AC function. Okay. Let's see another function. And let's see the function of the meter. The meter have a select key. When we first time open it, there is a DC. And put again, maybe to the AC. And long put again, then maybe turn to the NCV function. And maybe return by long part of this switch again to the original low impedance test function. In this low impedance mode, they have that may be 60 kΩ for testing the error fault voltage. Okay, another function. In this mode is a high impedance mode. In the first is a DC. Put this with again is a AC. And put this with maybe capture the peak value. Let's see, they have a peak value and hold the function. Put again is it dismiss. And they have a Hertz function key. when we put the Hertz function, then maybe in the downside is a frequency function, and the upper is a duty cycle. Okay, let's see another. The next function is turned to this position. That is through the die function on the continuity function. Put this with once for die test. Put again for continuity. Put again, maybe return to the original resistor function. And next is the capacity function. Then maybe use this way for measure the capacitor. Okay. Next function is a temperature sensor function. You can use the temperature sensor put in the meter, the bed in the left side, and the wet in the right side. And you can see that they have a temperature sensor. That is my temperature. Now it's rising up and testing the temperature. Okay. Next function. The next function is the current test. In the current test, in DC mode, they have a key for the first time for measure the accuracy reading. We must be pass this with long pipe. There may be rarity. The reading may be 10 to 0, and measure the reading may be accuracy. Okay, and next test for this meter in AC. In the AC reading, the top is Hertz, the downside is current, and in this position they have inverse current for measure by passing the middle of the switch long pipe. They have inverse current measure display on the reading on the screen. Sorry. Now it's in inverse mode for measure the current. Okay. The key function of the rarity only in the capacitor mode and the current mode. Let's see. Now it's in capacitor mode. Long part of this one maybe display the rarity mode. And also another function is current mode. In the current mode, DC or AC, they have passed this with long part maybe display the rarity like this. Now in AC, also by passing the long part of this one, maybe in rarity mode. Okay. Next. Reference DC test. Now in 2.5 watt. This meter is 2.515 watt. 5 watt. It shows 5.015 watt. 7.5 watt. It shows 7.50 watt. 10 watt. It shows 10.01 watt. Okay, next test. Normal AC voltage test. Now turn on. The first shows 220 watt AC. And this meter is a 221.6421. Sorry, 221.1. 221.1, and it shows the hertz, also show the hertz, and see that. Okay, it need a full make test. NCV test. In the NCV test, it must be put this with long put. Now it's in NCV mode. Let's see the meter. It about 5 cm maybe send the electricity. Near about 3 cm, that may be 2 bar. Near 1.5 cm, that may be 3 bar. Touch is 4 bar. And let's see the meter use the NCV function for testing the hot wire. Neutral. Neutral, no. Earth, no. Hot wire. Then maybe have a pisang and 4 bar come out. Let's see another. The back test lead. Neutral, 1 bit. And hot wire, they have a 4 bar. You can find the hot wire of the this meter. Okay, next test. Resistor test. 1 ohm. Your time for the reading is 0.9. 10 ohm. It's so 10 ohm. 10.4K. It's so 10.00K. 2 meg. It's so 1.996. 10 meg. 10.9 meg. It's so 10.93 meg. And bigger. $40 meg. It's so 40.93 meg. 61 meg. It overload, no any reading. Other lower. It not so. Over the reading. Okay. Let's see another test. Die test mode. Put this switch again for the die test mode, now in die test mode. It's so 0.533 watt. It's okay, you can check the die. Press again for the continuity mode. Let's see the continuity. It responds very fast. And your time for the reading Now test the sound. About 75 dB. Okay, next test. For the dynamo light on the LED, let's see the meter. Red, okay. Yellow, okay. Green, okay. Blue, okay. White, okay. It can light on all the LED. Next test. For the meter backlight, they have two. They have a light. They have a light on this wing. And parts again maybe dismissed. And in continuity mode, they say the meter say that there may be B sound under 50 ohm. Now see the bigger one. Now 40 ohm. 40 ohm also have a B sound. Now 15 ohm. Now 25. Now 30. Okay, it also have a B sound under 50 ohm. Next test. Capacitor test. There's a 10 mil. It's still 10.6 feet. Okay, next. There is a 1000. It's still 1.057. Okay. Next. Bigger one. There's 2200. The meter shows 2.005. Okay. Next test. For next test is reference capacitor. Now test the reference capacitor. It shows 120.7. It's very accuracy. And also see the resistor. Resistor is a 4.993. It's so accuracy of this meter. Okay, next test. Temperature testing. The room temperature FUB is 29.1, UT is 30.3, and ANENG is 29. Okay, let's test. And now it's in cool water first. Sorry. Cool water. And FUB is 1.7. And ANENG is about 2 degrees. And the unity is 2.4. Okay. We see the hot water. The hot water in FUB is 72.9. ANENG is 73. And unity is 17.8 degrees C. And ANENG for high temperature test. Now see the high temperature. It can now is 600, 300, 200 and cool down. Okay. This temperature sensor mix is 1000. Okay. Next test. And this meter mix is 2.8 kHz at sine wave at 6 watt. Next test. The meter big display mix is 148 kHz. The duty cycle may be very big into 64.8% duty cycle. Okay, next test. High DC current test. FUB is 9.88. This meter is 10.46. FUB 189 is 9.941 M. Okay. AC current test. FUB is 0.44 M. And ANENG is 0.44. And converter is 0.3. Next. And FUB is 0.75. And ANENG is 0.76. And converter is 0.8 or 0.9. Figure. FUB is 4.06 M. And this meter is 0.413. And converter is 4.3 M. Next. FUB is 5.76 M. And ANENG is 5.87 M. It also very near the FUB reading. And converter is 6 M. Okay. Next test. For the 10th time of the reading, we use the coil for testing. Now use the coil of 10 times of the current. And see the reading. The lower one. Fob is 4.6 amp. And ANENG is 4.57 or 56. And Capacitor is 4.3 amp. Now Fob is 7.8 amp. And ANENG is 7.78 amp. And Capacitor is 7.3 or 4 amp. Higher. The higher the Fob is 4.082 amp. And ANENG is 4.094 amp. And 40.91 amp. Fob is 40.82 amp. Capacitor is 38.6 amp. Higher. Fob is overload because there's 40. Try a bigger. It's so 57.8 amp. And ANENG is 58.08 amp. And Capacitor is 54.2 amp. And when near the coil, the Capacitor is 62.4 amp. Okay. Inverse current test. Now Fob is in inverse current, and this meter put this switch in the middle for the inverse. Long part. It may be 4 bar come out. And now test the inverse current. The inverse current of Fob is 5.5 and this meter is 5.7. Okay, next test. High voltage DC test. 100 watt. ISO 110.7 watt. 9.88 megaohm. Next test. 230. Fob is 276 watt DC. This meter is 276.1 DC. 500 watt. ISO 526.9 watt. Make a bigger. It will overload. The ANENG have a one sun and show the reading of 9.8 megaohm. And see the low voltage display. 100 watt. ISO 110.5 watt. Reading is 0.57 megaohm. It meets the reading of the meter of low ESET. 250. ISO 273.6 watt. And the meter is 0.57 megaohm. It meets the reading. 500. ISO 521.4 watt and 0.57 mega ohm. And now test the high voltage, 1000 watt. ISO 767 watt DC, 0.6 mega ohm. The meter no any one sign in the low Z position. Okay, test finished. Power consumption of the meter now supply is 3 watt. The draw current is 2.567 milliamp. And now open the backlight. And open the backlight is 10.481 or 2 milliamp. Okay, next test. This meter have auto power off function. When first time open the meter, they have a logo come out. There is in auto power off mode. If not use the meter 15 minutes, there may be auto power off. And if you want to dismiss the auto power off function, first turn off the meter and put the select function key and turn on. There are some B come out and the auto power off function logo may be disappear. Now time dismiss the auto power off function. And now I see the test the auto power off function. AC pit hole test. When the meter in AC pit hole test, it must be turned to the high impedance mode and select to the AC, and then put the switch in a pit hole function. And now it's in pit hole function. We use a capacitor test the low voltage. Now the capacitor have a high low voltage. It 5.374 watt. Discharge it and make a test in a high voltage for the supply voltage. Now display the supply voltage is 222.1 and it may be auto hold the function like this. Okay, next test for the DC voltage. For the DC pit hole function, we use a simple method for testing the meter. First, turn to the meter to the DC mode and long part of this one. Try the pit hole function of the DC now. We try the first one, AAA battery. Let's see. It hold the reading is 1.524 volt. Next one, it is a 4.2 volt battery. Let's see. The battery voltage is 4.187. It hold the high voltage. And now you are bigger one. There's a 9 volt battery. We try it. Negative, positive. Then we will show 9.43 volt in the peak hole function. Okay, next test. Meter teardown. Before I open it, there are 2 screws and a battery cover screw. And the left side and the right side they have a cap like this. And let's see the meter. There is the meter. They have a buzzer and a PTC for protest. Content of the battery, crystal, the main IC, and the resistor component, and also I have a PTC. They have the push button, and the downside of the battery compartment no any shielding. Okay, let's open the meter. And this meter have 2 anchor in this 2 and this 2. You have to see. They have an angle for fixing the left or right side. And before we must be check out the angle first. Now open the left side and open the right side. That's right side. They have a map. Okay, now open the meter. Before open the meter, the white strap may be pulled off. Now pull off the white strap. They have some screw in the bottom. At the top, Now fully open the cap meter. They have a wire strap for the NCV. Okay, light up the board. Okay, that open. They have a gold contact of the selector cable, selector loop, and the LCD skin. There is, and the push button, and that is the back side of the circuit board. They have a backlight skin, and there is a LED board. And in the downside, no any component, and a cap. See again. And no any other component inside. Okay, teardown finished. NCV test. It about 2 cm have 1 bar, and touch is 2 bar.